I'm Bridgid and I will be speaking to you today about ocean acidification and its effects on marine life.
So what is ocean acidification? Ocean acidification is when there's carbon dioxide in the atmosphere, but it also dissolves in the ocean. The carbon dioxide in the air is released by the burning of fossil fuels, and around 25% of this goes into the water. When the carbon dioxide dissolves in the ocean, this causes the water to become more acidic and the pH drops. At first, scientists thought this was fine because there would be less pollution in the air, but they didn't know the downsides. So in my picture here, it says, oceans absorb carbon dioxide from the atmosphere, creating carbonic acid in the waters. So carbon dioxide plus water, that creates carbonic acid, which is the problem for ocean acidification. And I will be explaining the problems in later slides. Ever since the Industrial Revolution, when ocean acidification first started, the ocean has collected 525 billion tons of carbon dioxide a year. This means there's 22 million tons a day going in the ocean. Over the past 200 years, water became 30% more acidic, which is faster than any known change in ocean chemistry in the past 500 million years.
So first off, I will be talking about the effect on coral reefs. Ocean acidification affects coral reefs by it's harder for corals to build their skeletons. Since corals grow upwards towards the sunlight and they get thicker. However, with ocean acidification, it lowers the skeleton's density and they're more vulnerable to breaking and erosion. Scientists predict that by 2080, the ocean will be so acidic that coral reefs will be eroding more than they can erode. This also affects the organisms that live in them. So the picture right here I have is before and after because of ocean acidification. To the left, you see the corals are really nice and purple and healthy, but after it's all like white and it's all like gross looking. So that's what happens. So the effect on shelled animals. Shelled animals such as mussels, clams, and starfish, they'll have trouble building their shells in the future. By the end of the century, mussels are expected to grow less shell up to 25%. Because of this, there's an increased chance for predators to crush and eat them. Bisothreads are also affected by ocean acidification, and these are what mussels use to move around and hold onto rocks. Lastly, the acidic water is not affecting all shelled animals, which is interesting. So animals such as crustaceans, lobsters, shrimps, crabs, they're growing stronger shells because of ocean acidification, which is interesting. Also, scientists have discovered that purple sea urchins are adapting to this new water. So scientists think that they could adapt to this in the future. So the picture down below, as you can see, this is a mussel. And if you see the yellow like spikes at the bottom, those are the bisothreads, and that's how they, like I said, that's how they move around. So zooplankton are kind of similar to shelled animals. They don't handle acidity fairly well, and so the shells will dissolve quick. This is especially bad because the shells are made of aragonite, which is a type of calcium carbonate, and this is 50% more soluble in water, which means it'll go quicker. So the picture below, this is of a zooplankton, and as you can tell, through the span of over a month, 45 days, the quality of the shell goes significantly down. As you can see, 0 days, it's all nice. 15 days, it gets like whiter. 30 days, it starts to get faded, and in 45 days, you can barely see it. It's mostly gone. So the effect on plants and algae. Since plants and algae make their energy from photosynthesis, the carbon dioxide actually helps the plants, and they can actually thrive under acidic conditions. Of course, this isn't for like every single species, but this is just in general. So the effects on fish, although it doesn't affect them like significantly, just like unlike the coral reefs and stuff, they still feel the effects. With fish, the carbonic acid in the water, it affects the fish cells. And because of this, the fish get acidosis, which is when the fish blood changes pH level, which isn't good. So to bring the chemicals back to normal, their body goes into a sort of overdrive. However, this reduces the fish's ability to reproduce, eat, swim, and growth, so it prevents them from doing normal activities. It can also affect the fish's mind, such as not running away from predators, and they have trouble smelling their way back home, so it affects their whole system. So for my conclusion, what's the relevance of ocean acidification to us? It's relevant to us because it affects the US economy with sectors such as fishery and tourism. With the carbon pollution, shellfish are growing slower, and this is causing multi-million-dollar losses to West Coast economies. Also, since the acid is built up in the shellfish, it can become dangerous to humans to eat. So fisheries need to close because they can't sell them to us. By the end of the century, it is expected that the supply of clams will go down by 35%, oysters by 50%, and scallops by 55%. Lastly, with climate change, it will become worse because the plants and algae will not be able to absorb CO2. What will happen in the future? If fossil fuels continue to keep burning and ocean acidification continues, the pH of the salt water will become even more acidic, which isn't good. So in the picture down below, this is present day to the left, and as you can see, it's more basic level, kind of below 8.1. And then you can see in the middle, this is in a perfect world what would happen in 2100 with CO2 reduction. So it'd hopefully be the same. But if there's no CO2 reduction, it goes down to 7.3, which is like 1 point less acidic, which is not good. So what can we do? To limit ocean acidification, we need to act on climate change and reduce the use of fossil fuels. If we do this, we can reduce the harm to fisheries and not have a fish catch decline. Studies also predict that with significant emissions reduction, 30% of coral reefs will be spared from extinction. You can also reduce the level of carbon dioxide you use by recycling, walking, biking, carpooling, turning off lights, etc. And you can also educate others about ocean acidification and how bad that is. So that is it for my presentation. These are all my sources cited. I hope you enjoyed it, and I hope you have a great day.